Electrical current is the rate at which electrons flow. So current is the charges moving divided by time. And the charge we measured in coulombs, time is measured in seconds, so we measure current in coulombs per second, which we call an ampere, or amps. The symbol for current is I. So if I have electricity flowing at 5 amps, that means that 5 coulombs worth of charge passes a point every second. There are a couple different ways to make electricity flow, to make electrical current. Charges flow from a higher potential difference to a lower potential difference, and some external source must add in energy to the particles in order to keep them moving. We had this same kind of motion happening with static electricity, but it was one big burst. This is a continuous flow. So in order to keep it going, we have to have some extra energy added in. Remember that potential difference is the electrical energy available per charge. And there's a couple different ways of looking at potential difference. You can think of it as the energy available to move electrons, or the difference in the density of electrons, where most of them are. So one of the main sources of potential difference is an electrochemical cell. And they convert chemical energy into electrical energy. Remember that chemical energy is energy stored in bonds and molecules. Examples of these are batteries and galvanic and voltaic cells. And these work through a redox reaction, and there's wet cells and dry cells. And let me show you some pictures while we talk about it. So this is a wet cell, and it's called that because this blue and green stuff is actually a liquid. And they have electrodes in there. They have a salt bridge. And this copper electrode has a redox reaction with this sulfate. And what happens is the sulfate ions flow through the salt bridge and then flow through the light. And it makes a continuous circuit. These are the kind of batteries in your car and boats. If you've ever shaken that kind of battery, you've noticed that there's some liquid in it. The kind of batteries you come into contact with most often are dry cells, like AA's and AAA's and all of that. And instead of this liquid, they have a paste. So the redox reaction is between this rod and this paste. And it causes the electricity to flow. Some other sources of potential difference are generators. They convert mechanical energy into electrical, and we will talk a lot more about them soon. You can also have a photovoltaic cell, and the name tells you photo, light, voltaic, electrical energy. So they convert light energy into electrical. They're also called solar cells. You also have piezoelectric crystals. These convert pressure applied to the crystal into electrical energy. What happens is inside the crystal is a very, very structured order. And when you apply pressure, it deforms that order and it causes electrical current to flow. You actually use piezoelectric crystals sometimes as buttons. Like on a calculator, when you press it, you're compressing that crystal and it sends a pulse of electricity.